this size machine and went from, say, 100 gallons to 1,000 gallons. And they're like, holy man, it's the right process to get where they want it to go, but it's not economically feasible. Oh, I just spent $250,000 on this piece of machine and I can't get where I need to be.
The amount of product that gets trashed because of quality assurance.
Most people think manufacturing's dirty, boring, or dying. They're dead wrong. This is Manufacturing Runs the World. We're here to fix the misconceptions, teaching the next generation how modern manufacturing really works and why it matters more than ever.
Why don't you tell me a little bit about yourself? What is your career path that led you to working with Orbis?
So I have about 23 years of engineering design experience. Worked at various different companies. My start out of college was working with trenchless technology, building pneumatic hammers and basically really heavy, robust equipment out to pound in large casings, replace sewer, water, and pipe, electrical service type application. Very hard on products like we're breaking steel and bolts and high cycle, high fatigue type application.
Yeah.
So from there, I moved into another place that utilized sampling. So they basically process equipment and sampling of products. I worked there for 5 years doing code calculations for their piping and process industry products and designing to make it easier for customers to get a sample while they're running process and evaluate, is it done yet, essentially. Combination of those two career paths led me to Orbis, which was, designing heavy duty industrial equipment, an aspect of ASME pressure vessels and jacketing systems on the equipment.
You're talking about all these specific terms within the industry. What is the end product that a lot of those things generate?
It's, feedstock for deck boards. It's feedstock for silicone tubing, feedstock for, pharmaceuticals, which could be like baby care products. It could be hoses and instrumentation for, you go to the hospital and they have like the throwaway hoses or syringes. It could be a byproduct of, the connection of that tube if they're drawing blood, that types of products.
So do you just go out in the world and you look at these things, everyday products, and you're like, I probably made something that went in that.
We probably make the base stock that goes into making that, so the end user takes the product that comes out of our machine. It's either in a billet form, just a chunk of raw materials that's mixed to the chemistry, and then it goes through an extrusion machine where it's heated up and further processed into those different structural components. They make products.
Yeah, cool.
Another new customer that we're just energizing and engaging with, they make like caulkings and silicones like around your windows. So like a high density sealant that goes around like the glass. So then when the changes of the seasons come, you don't get a drafty window. It's sealed with that compound.
Yeah, I just think it's so cool to think about stuff like the seal on a window. And you don't really think about the process it went through to get to that point of product where, a contractor is using it and actually sealing the window. And especially the scale of it, right? Because they have to make so much of that product. How are they doing that? It's cool to see where it starts from, because the double R mixer now is they take that raw material from the mixer and then they put it through the process to either extrude it or process it for their sale. Is there ever any major problems that you've seen that a customer has come to you with?
There's been a few. Some of them, revolve around the Sigma blades and the sealing components that hold the product within the machine. So with heats and, heating and cooling, you get expansion and contraction of the equipment. And then as you're processing it, the process tends to run down the shafts and want to leak out or find whatever nook and crannies. Our equipment is fairly sealed and tight, but when you have moving and rotating shafts and access ports, you're prone to having leaks. The industry standard is, sort of a rope packing, smash it in there, a regular PM maintenance just to keep the tension on that rope packing tight and secure to the shaft to prevent leaks. There's new technologies out there, incorporated air seals with a few of our customers, and it's been a very significant improvement to their PM schedule, and they loved it so much we prototyped it, tested it, and they retrofitted all of their equipment now to this air seal. So it's very cost effective. The maintenance PM schedule dramatically decreased, and their maintenance team is working on other bigger problems. So
yeah, and you've been in this industry in some form or another for the past 20 years, right? What are
Correct.
some of the more modern things that are happening in the industry?
I think it's, the service side of things is really, a lot of it's being lost. Interaction between the design side, providing the value that customers see. We're interfacing with them face-to-face, doing online design sessions, but we're also going in person, looking at the equipment and, look at the pain points and say, hey, what can we do to help you better so that we become better, you guys are more productive.
Does that happen often where a customer comes to you, they have a specific problem, and then you steer them down because you guys have lab processing, right? And lab testing?
Yes. So we have a small lab and we can get some basic data from, running some small batches. Very helpful for us because then we can do those, process the horsepower to torque requirements. It also gives the customer an opportunity to see, is this the right piece of equipment for the job? We've had a few tests where they're running it and it's like, okay, nothing happened. Okay, well, this is definitely the wrong piece of equipment for you then.
Yeah.
Something's happening, but it's not getting there as fast as we want it to. What can we change in variables to improve the process time? And we've had a customer that came in here and it was like grinding this, recycled product up for them. And it's like, okay, it's not getting to the size that they need. What else can we do? So we changed a media charge in a ball mill, and we just said, well, let's throw this at it and see what happens. And lo and behold, it was a game changer. Like nothing happened in the first two tests, and all of a sudden we did this, and then boom, they're like, oh, that's exactly what we want. I was expecting this size of a piece of equipment, that I'm going to purchase if this works. And then, share the numbers with us on what their yearly or monthly output is going to be. And we're like, no, you need like this size machine, and went from say 100 gallons to 1,000 gallons. And they're like, holy man, I was not anticipating that. So that might be a game changer for them because they weren't budgeting the capital expense to buy that piece of equipment to meet their production needs. So it could also be that it's the right process to get where they want it to go, but it's not economically feasible. So maybe in that light, it's not the right piece of equipment for their production rate. But right. You learn that up front relatively cost effectively versus, I just spent, $250,000 on this piece of machine and I can't get where I need to be. So
do you ever sit around with your buddies having a beer and you're like, this one time when I was working on this engineering problem, this happened?
I don't have any off the top of my head, but there's a couple out there, but I don't know if I can freely talk about this.
Those are the ones we want.
It didn't involve our equipment. It was on the processor side, and he told me about the story, and I was like, whoa. It gives you an idea of what could go wrong, just with chemistry and process, and the ramifications if you don't have the engineering behind the design. Would say you learn from those experiences that you don't want to put either your customer in that situation or yourself in that situation. So
yeah, a couple of them that come to mind, again, because I ask this question a lot of people. I think one that sticks out to me is just the amount of product that gets trashed because of quality assurance. One specifically was like in the medical industry when they're machining parts, and if it's not to spec, if it's off by a little bit, they have to scrap it. So it's tens of thousands of dollars, hundreds of thousands of dollars sometimes a month worth of product is just scrapped in the name of QA.
Sure. Related to this PM schedule that I spoke about earlier on seals, so this particular customer who switched over to these air seals with the rope packing, that was truly a concern. Their product had contaminations that were coming in from the rope packing. And they would either have to filter the batch out, which they, to my knowledge, they can do to some extent. But if there's so many parts per billion and pharmaceutical grade, yeah, they have to throw $20,000 to $30,000 batch of silicone away, or they have to downgrade it to industrial uses. With their advent of going to these air seals, they have essentially eliminated that part of the contamination cycle, because there's not only the processing can provide contaminants, their input ingredients provide places for contaminants to come in. Like he was showing me their screening process, and they're pushing basically this really dense silicone through these screens, and they're picking up like minute pieces of like fiber and steel, and like, where did that come from? Like it's unbelievable on different, contamination sorts. It could be parts from the bag that they dumped it in, if it was a fibrous bag, or something from their supplier that got into the product and they didn't filter it out. So this stuff gets expensive really fast.
Interesting. So when that problem comes across your desk, does that mean you're jumping on a plane and you're seeing where the machine is installed and replacing screens? And are you boots on the ground when that happens?
It's boots on the ground to say, hey, is the equipment causing some of your pain in your filtration of this product? Can we eliminate that contamination point? No, it isn't the seal. Is it some part of the mixer rubbing steel on steel that you could minimize that potential hazard, design clearances and such that give it more forgiving expansion, contraction capabilities and still perform? We bring that back and we incorporate improvements in our design, so we learn, and customer then benefits on new designs as well.
Well, Nathan, thank you for your time.